Hello mathematicians, puzzlers, and other curious people. In this video, we're going to see how we can calculate a line that goes through 2 points just from the coordinates of those points. Now, here's an example of a time when that happens. So if you're using the GeoGebra graphing calculator and you plot 2 points and then use this line tool to draw a line through those points. In the background, it's doing all these calculations for you. So let's take a look at an example. So let's look at a line through 2, 4, and 8, negative 3. 2, 4, and 8, negative 3. So there's those 2 points, and here's what a line through those 2 points looks like. To draw that line, GeoGebra it's a computer program. It can't actually work on some paper and hold up a straight edge to something and draw a line through it. It's not capable of that. It's all virtual. It does everything with pixels and numbers. Well, what numbers? Well, these numbers. Now there are a couple of different versions of this particular formula. The other one is maybe a little more common, but I'm particularly fond for the point slope form of an equation of y equals m times x minus x1 plus y1. Now you may have seen a form where the y1 is on the other side as a negative term. I'm particularly fond of this form because I feel it's the most similar to something later on that students need to do, which is something similar with quadratics, the vertex form. But we're not there yet. We're just focusing on a line through 2 points here. Now I'm just going to use 2, 4 because it doesn't really matter which point you use. And so it's always a little easier if everything's positive. Now what about m, the slope? Well, let's see, if we've got a point at 2, 4, I'll let that be 2, 4, so my origin would be there. And we've got another point at 8, 4, 6, 8, negative 3. I see our slope will be negative because we've got a decreasing function. So we've got a rise of negative, let me double check that, 7, and a run of 6. And you can calculate that numerically rather than graphically by saying, okay, negative 3 minus 4 over 8 minus 2. And again, that's going to give us negative 7/6. Then just copy in the rest of the formula. And you can actually already use this for problem-solving purposes, but it's useful if you go ahead and, also simplify it a bit. So we'd have negative 7/6 x plus, well, let's see, that'll cancel, 7/3 plus 4. I know another way to say 4 would be 12/3. So in all, we'd have negative 7/6 x plus 19/3 as the slope-intercept form of this line. Now let's just see if that's what GeoGebra got for this line through 2 points. Whoops. Okay. So GeoGebra wrote it out in decimal, but Yeah, it's the same numbers. You can grab a calculator and verify that they really are the same. So take a moment and try out this problem here. I'm going to go on, but you can hit the pause button for a moment. Okay, so let's see. We've got -1 minus -3, so that's just like +3, over 7 minus 5. Always make sure that you've got your x value and y value from each point lined up vertically. So here we have 2, whoops, I spelled 2 with a 3. That's wrong. Easy to fix, fortunately. Okay, so we've got a slope of 1. Well, that makes this part easy. Then when we say, well, y would be 1 times x minus, well, either way, I've got a negative here, so I'll just say x plus 3 plus 5. So we've got x plus, I can see where this is going, 3 plus 5 is 8. So again, we can check this by running it through GeoGebra, and we would be able also to sketch it out and check that those points are on it. We can also check it by plugging in each x value and see that it gives us the right y value. Okay, so that's what I've got for you in this particular video. So for now, I'm going to say calculator.